Hi everyone, it's Elliot from TutorialEdge.net, and in this tutorial we're going to be building a really simple REST API in Go using the new up-and-coming framework called Fiber. Now, as always, the full text version of this tutorial will be available on my website, and I'll leave a link to that in the description below. Now, why Fiber, you might ask? If you're coming from another language and trying your hand at developing Go applications, then Fiber is an incredibly easy framework to start with. It presents a familiar feel to Node.js developers who have previously built systems using Express.js, and it's also built on top of fast HTTP, which is an incredibly performant and minimal HTTP engine built in Go. So, with the introductions out of the way, let's dive into Visual Studio Code and start writing some code. Now, the first thing I'm going to want to do in my directory is initialize it using Go modules, so go mod init, and I'm going to pass in github.com/ElliotForbes/Go Fiber tutorial, and I'm going to create a new file called main.go. Now, this main.go file is going to be the entry point for our REST API that we're going to be building up, but for now we're going to build a really simple server just to show how the Go Fiber framework works. So first of all, we're going to import Go Fiber, and we're going to define our main entry point. And within this, we're going to define a new app, so fiber.new, in order to instantiate a new Fiber application. And we're going to define a new app root, which will be available using a HTTP GET request, which will be mapped to a hello world named function, which we'll define in just a second. Finally, we're going to tell our app to start listening on port 3000. Okay, so let's define the hello world function, which will take in a pointer to the Fiber context. And within this, we want to call C, which is the context.send, which will return a hello world response to anyone making a HTTP GET request to this particular endpoint. Awesome. Now with this in place, we want to then try and run this application using go run main.go. And as you can see, this will go away and start running our Fiber app on localhost port 3000. And just to verify that, we can come back into the browser and open up localhost 3000 like so. And as you can see, I'll make this a little bit bigger for you, it has successfully returned hello world. Awesome. Now in this tutorial, we're going to be building a book management system, which is going to allow us to store in a SQLite database the number of books that we've read during this pandemic, and do things like delete books, update books, and retrieve single books. Now, in order to do that, the first thing we're going to want to do is define a new book package. So I'm going to call it book/book.go, which will create a directory called book and a new file called book.go within that directory for us. Now, it's within here that we're going to define all of the logic for getting, retrieving, updating, and deleting books. So basic CRUD functionality. Now I'm going to start off by defining the book package, and I'm going to import the Fiber framework as well, so github.com/gofiber/fiber, and I'm going to create the stubs for all of the functions that we're going to be defining within this tutorial. So get books, which will take in a context, or pointer to a Fiber context, like so, and it's going to simply send all books for now. And I'm going to copy and paste this 4 times. And I'm going to modify the second one to get a singular book. The third one is going to be new book, which will add a new book to our database. And the final one we're going to be defining is delete book. Cool. So we've got these 4 endpoints in place. I'm going to leave out update book for now, and I'm going to leave that as an exercise for the viewer. Now, with these functions defined, we're going to want to map new API endpoints to these functions so that our application can start returning all books, a single book, adding a new book, or deleting a book. So we're going to open up the main.go file again, and we're going to modify this slightly. So we're going to create a new function called setupRoots, which is going to take in a pointer to our Fiber app, like so. And within here, we're going to do the following. So app.get to define a get API endpoint. And we're going to define the path, which is going to be API/v1/book. And this is going to point to the book package.getBooks public function or exported function. Now, as we're going to be using this package, we're going to have to import it. So come up to the import block and do github.com/ElliotForbes and spell my name right. So Go Fiber Tutorial and book like so. Now let's start by defining the other three endpoints that we're going to be using. So get API v1 book, and this is going to take in a path parameter for the ID of a particular book we want to return. And it's going to interact with the book.getBook function, which is the one that returns a single book. Next, we're going to want to do app.post API v1 book, and this is going to be the new book function. And finally, we want to do app.delete API v1 book, and just like the single book endpoint, it's going to take in a path parameter for the ID of the book that we want to delete, and it's going to call the book.deleteBook function like so. Perfect. So the next thing we need to do is modify our main function and remove the hello world endpoint and call the setup routes function that we've just defined whilst passing in the instance of our app like so. Cool. With this in place, we can then try run our application by opening up the terminal and calling go run main.go. And as you can see, this has started our application running on localhost port 3000. Now we can come back into the browser and we can add API v1 book. And as you can see, it's successfully called our book package.getBooks function to return all of the books, or the placeholder string for all of the books. Cool. So now that we've tested the all books function, we're also going to want to test that the other endpoints are working correctly. Now, the best way to do that is to open up another terminal and use the curl command in order to interact with these endpoints. So the first one is going to be http localhost 3000 API/v1/book/1, and that returns a single book. The next curl command or request we're going to want to do is xpost, which is a post request into the new book endpoint that we defined, and this will be http localhost 3000 API v1 book, which adds a new book. And the final one we want to test is xdelete, which sends a http delete request into this endpoint here. So http localhost 3000 API v1 book and ID of 1 like so, which deletes a book. Brilliant. So all four endpoints have returned the proper response for their respective HTTP requests. So now that we have the respective endpoints all defined and working as expected, let's have a look at setting up a simple database that we'll interact with using Gorm. And first thing we're going to want to do is to create a new file under a new directory called database. So this is going to be database/database.go. Now within this, we're going to define a database package, so database, and we're going to want to import the following packages, so github.com/jinju and gorm, and then we're also going to want to import the driver or the dialect for SQLite, so github.com/jinju gorm dialects and SQLite like so. Now within this package, we're going to want to define a global variable called dbcon, which will be the pointer to our DB connection, so gorm.db, and this will be effectively passed around all of our book endpoints, and it'll allow us to use the behind the scenes pooling mechanism to talk to the database and perform any updates we want. So the next thing we're going to want to do is to open up the main function, and we're going to want to import this new package. So I'm going to steal the import to the book package and then just modify it to import database. like so. Cool. So the next thing we're going to want to do is to initialize this database connection, and we're going to do that within a new function called init database. Yep. Now, I'm going to define an error, so var error, and we're going to say database, the database package .db connection, or error equals gorm.open using the SQLite 3 dialect, and we're going to call this database books.db, like so. Now, as we're getting an error, we're going to want to handle that error, so if error does not equal nil, then we're going to want to just simply panic, failed to connect to database. Cool. And then if it doesn't panic, we're going to want to fmt.println database successfully opened, or database connection, like so. Now, as we're using format, or the format package, we want to make sure that we've imported it up at the top, which we have. And we're then going to want to come into the main function to call this init database function. And as we're opening a connection to a database, we also want to defer the database.db connection.close, just to ensure that it doesn't keep those database connections open longer than we want them to. And one last thing we're going to want to do is to open up the imports block and add the github.com Jinzu Gorm import to the main function, or the main package, and github.com Jinzu Gorm and dialects / SQLite, like so. Dialects. Cool. So we're going to want to open up the original terminal session and Control-C that running instance, and then just rerun it using go run main.go. And as you can see, it prints out that the database connection has been successfully opened, and our Fiber app starts running on localhost port 3000. And you should also see within your file explorer on the left hand side the new books.database SQLite 3 database being created. Perfect. So as it stands, our books.database is currently empty. It doesn't have any tables that we can interact with. So the one thing we're going to want to do is open up the book package, and at the top of this we're going to want to define a book struct, which will model how the books table is going to look within our database. So within this we want a title, which will be of type string, and the JSON for this will be title, and then the author, which again is going to be type string, so JSON author, like so. And we're also going to add a bit a rating for a bit of fun, so JSON rating. Cool. So as we're using the gorm.model here, we're going to want to import the gorm package, so Jinzu gorm, like so. Save that, and then we're going to want to open up the main.go function and open up the init database function so that we can come in here and then do an auto migration. Now this auto migration will take in the struct that we've just defined, and it will create a table for us and update table values without deleting or removing any existing data. So in order to auto migrate, we have to do the following. So database.db connection.auto migrate. And as you can see, the definition for this is auto migrate runs an auto migration for given models, will only add missing fields, it won't delete or change current data. So it's safe to call this on app startup every time. Now we're going to want to pass in book.book, like so, and just under this we're going to want to fmt.println database migrated. Perfect. Let's just double check that runs. So go run main.go. And as you can see, it opens up the connection to the database that's already existing, and it has migrated the database to include our new books table. So we've now got the database in place, we've got the table in place within that database, and we have our REST API endpoints mapped to the functions within our book package. The final thing we're going to want to do is to update these functions so that they interact with the database and return the data as JSON. So the first one we're going to do is the getBooks function. And we're going to say database equals the database package.dbcon. And I like doing this just for cleanliness. And we're going to do var books, which will be an array of type book. And then we're going to call db.find to retrieve all of the books and populate our books array here. Now the final thing we're going to want to do is to use the c.json function, which converts any interface or string to JSON using JSON iter. And it also sets the content header to application JSON, so that's important, and we'll see why in a little while. So I want to remove this string and just pass in books, like so. Now, because we're using the database package, we're going to want to make sure that we've imported this at the top. So Elliot Forbes /go fiber tutorial /database. Perfect. So let's just double check this works and incrementally build up our application. Go run main.go. The application is started. Let's open up our second shell, and we're going to want to define a new curl command. So the curl command we're going to want to do is http localhost 3000 API v1 book. And as you can see, that's gone away and tried to interact with the database. It's then seen that there are no books currently in the database, and it has then serialized this array of books into a JSON response. Perfect. So we've defined the getBooks method. Let's now focus on retrieving a single book from the database and returning it as a JSON object. So I'm going to clear out the getBook function, and I'm going to say id is equal to c.params, which is the function that we'll use to retrieve the particular root parameter that we've defined within the main.go file, just up here, which is called id. So this will return that id. We're then going to want to do database equals database .dbcon. Going to define a book, so the var book of type book, and we're once again going to call the db.find, passing in the reference to the book and the ID. Now if it finds something, we're going to want to serialize that as JSON and return it to the requester. Perfect. So we're keeping this nice and simple for now, but we're going to add some error handling and some advanced status code in the adding and deleting books endpoints. So let's now focus on adding a new book. So once again, database equals database.dbcon, and the book is going to be a type book, and we're going to hard code the fields of this right now. So we're going to say 1984 book.author is equal to George Orwell. Hope I'm spelling that right. And we're going to give the book rating 5. Now with this book defined, we're then going to want to do the following. So db.create, passing in the book, and just to sort of return a response, we're going to do c.json, the book. Perfect. So we can now test this application and see if it's successfully inserting books into the database. So I'm going to Control-C the existing server, run it again, and as you can see, database connection successfully opened, database migrated, and I'm going to open up the second terminal, and I'm going to run a few curl commands. So the first curl command is going to be to retrieve all the books. So http localhost 3000 API v1 book, which returns an empty string for now. And we're going to want to call the post endpoint, so x post http localhost 3000 API v1 book. And as you can see, it returns the ID and the JSON object of the book that has populated into the database, which includes helpful fields like created at, updated at, deleted at, as well as the 3 fields that we've defined within our book struct. Cool, so if we run the original curl command again, we should see that our array now features one book, which is exactly what we wanted. Now the final endpoint we're going to define is the delete book endpoint. So within this, we're once again going to want to get the ID for the book we're going to delete. And we're going to want to get the database, so database.dbcon. Oops. We're going to define the book, so var book. And we're going to do db.first and book, passing in the ID. So that'll search for the book with that given ID. And then it's going to say if book.title equals null, then the book hasn't been found. We're going to send a status code, so c.status of 500. And we're going to send a message saying send no book found with given ID. And at this point, we're going to return. Cool. If a book has been found and it does have a title, we're going to then call db.delete, passing in the book. And we're going to do c.send, and I'm going to be lazy and just send a string, book successfully deleted. Awesome. So let's once again test this. So we're going to Control C our existing server, run it again, open up the second shell, and as you can see, the book still exists within the database. So let's try and delete that book now by calling the delete endpoint. So we're going to modify this existing curl request, x delete, like so. And if we press enter on that, we should see book successfully deleted. So when we retrieve all of the books again, it has successfully deleted it from the database. Perfect. So the final thing I want to cover in this tutorial is reading the body of an incoming request and parsing that into a book struct so that we can populate custom data into our database. Right now, if we have a look at the new book function, you can see we've hard coded all this, which isn't ideal. Now let's delete this for now and keep the surrounding logic for inserting the book. And we're going to want to do book is equal to new book. And then we're going to want to do if error equals c dot. And we're going to use the body parser function, which binds the request body to a struct. And it supports decoding the following content types based on the content type header. So application JSON, XML, form data, or URL encoded, which is really quite handy. So form, body parser, pass in the book. If error does not equal nil, then we're going to want to again return a status 503, and we're going to want to send the error before returning. If it has been successful in unmarshalling or deserializing this book into a struct, then we can then use that to insert into the database, which we've already got below, sorry. So this line here will take the populated struct and then insert it into the database. So save that, and we're going to want to once again close this server, restart it, come into the terminal. I'm going to clear this just to make it nice and clear, and we're going to want to do another post request. However, this time we need to specify the content type, which will be application/JSON, and the data is going to be an escaped string or JSON string. So the title is going to be angels and demons, and the author is going to be Dan Brown, and the rating is going to be 5, like so. And next we're going to want to define the endpoint we're going to hit, so http localhost 3000 API v1 book. And what have I done wrong? X post data date 2 seconds. It's not date, it's data. And there we go. And as you can see, this has successfully inserted a new record with an ID of 2, which is auto-incremented from 1 previously. And you can see the title is Angels and Demons, the author is Dan Brown, and the rating is 5. Now, one final validation, we can check to see the getBooks endpoint. As you can see, only our one newly populated book exists within this database. Awesome, so that's all we're going to cover in this tutorial. We've managed to cover quite a lot. I realise it's quite a long tutorial, so thanks for bearing with me. In this tutorial, we've been able to create a really simple REST API for a book management system in Go using the new Fiber framework. Now, I really hope this has helped you out and that you enjoyed the tutorial. If you did, then please let me know in the comment section below. Please leave a like and subscribe to my channel for more programming content. Cheers!